Hello everyone, I welcome you all to my online classes. This is Om Maths Corner. Today we shall discuss indefinite integrals. This is the name of the topic of the day for the students of class subject mathematics. Today we shall discuss very important questions to the examination point of view. Revision plan. If you have completed one time the whole syllabus of the book, after covering the syllabus, this is the revision plan for this particular chapter. Revision plan, we are discussing here very important questions of the topic. So let us proceed now. Question number 1, evaluate integration sine raised to power 6x plus cos power 6x whole divide sine square x into cos square x dx. So what we do here, there is one trick. What is that? We convert the numerator as sine power sine square x whole raised to power 3 plus similarly here cos square of x whole power 3. Denominator is same, sine square x into cos square x. Now see the numerator, aq plus bq. What is the formula? aq plus bq, which is equal to a plus b into a square minus ab plus b square. Okay, so here what we do, we take a equal to sine square x. So the whole question becomes integration of a plus b, that is sine square x plus b mean cos square x into a square, that is sine square whole square is, we can say sine square x whole square minus ab, that is sine square x into cos square x plus b square cos square of x its whole square, and denominator is the same, see this way, into dx. Now sine square x plus cos square x is 1, we are left with this only, sine power 4x minus sine square of x into cos square of x plus cos raised to power 4 of x whole divide this value same, okay, into dx. Again we can write this equal to sine raised to power 4 upon this, which is equal to sine square x upon cos square x, right? Next is minus sine square x into cos square x, denominator is also same, so only 1. Likewise here also plus cos power 4x upon this, which is equal to cos of cos square x divide sine square x into dx. Now first term is tangent square x. Tangent square x we can write, as we know the rule, secant square theta minus tan square theta is equal to 1, which implies tan square theta is equal to secant square theta minus 1. So here we substitute this value, that is tangent square x value is secant square x minus 1. Next term is minus 1 plus this is cotangent square x, and we know the formula, cosecant square x minus cotangent square x is equal to 1, which implies cot square x is equal to cosecant square x minus 1. So here we substitute this value, cosecant square x minus 1 in place of cotangent square x into dx, right? Now very simple, what is the integration of secant square x? Of course this is tangent of x, minus 1 minus 1 minus 1 minus 3, and integration of minus 3 is minus 3x plus cosecant square x integration is we have minus cotangent x, minus cotangent of x. Okay, lastly we write c, the constant of integration, right? So conclusion is this becomes minus tangent x minus 3x minus cotangent x plus c. Okay, so this was our question number 1. Question number 2, evaluate the integration of sin 2x divide a plus b cos x whole square into dx. Here in such type of questions what we do, denominator a plus b cos x, we substitute this is equal to t. Substituting a plus b cos x is equal to t. Now taking the derivative both sides, minus b sin x into dx is equal to dt, right? We apply this in the given integral, that is the given integral I can be written as sin 2x which is equal to 2 into sin of x into cos of x whole divide a plus b cos x its whole square into dx. From this line, first line, we can conclude the value of cos of x is equal to t minus a upon b, and from second line we can conclude dx is equal to dt divide minus b of sin x. We substitute these values here now, integration 2 as it is, sin x as it is, cos x value is t minus a upon b, cos x value is this, into dx is equal to dt divide minus b of sin x whole divide a plus b cos x which is equal to t, so it's square. Now next step, sin x cancelled, minus b into b is b square, so 2 upon b square minus taken outside, integration of t upon t square is 1 upon t, a upon t square minus a upon t square into dt. Now its integration is minus 2 upon b square into 1 upon t integration is log of t minus a upon t square integration is plus a upon t plus c the constant of integration. Now we just substitute the value of t here like this, log t, t mean a plus b cos x, a upon t mean a plus b cos x plus c the constant of integration. So this was our question number 2. Question number 3, evaluate integration 1 upon sine of x minus a into cos of x minus b. Here we follow one trick. What is that? We multiply and divide by cos b minus a divided cos b minus a multiplied. Okay, this is constant. Denominator no change, we are writing as it is, denominator no change, into dx. Now next, one more thing in the numerator we are introducing here, x. How? This way, x minus a minus x minus b. On solving we just get cos b minus a. Okay, now remaining terms, that is denominator no change as it is. By doing this, what happens? Cos a minus b formula, what is that? Cos a minus b is equal to cos a cos b plus sin a sin b. Here what is a? A is x minus a, b is x minus b. So we apply this formula here. Cos a minus b is equal to cos A cos B plus sin A sin B. Denominator as it is into dx. Now next step, first term divide denominator, second term divide denominator. First term divide denominator plus second term divide denominator. So this way into dx. Now what happens? Cos x minus b cancelled. Here sin x minus a cancelled. So we are left with cos x minus a divide sin x minus a plus sin x minus b upon cos x minus b. Now numerator is the derivative of denominator. So we apply this rule, integration f dash x upon f of x is dx is equal to log of denominator plus c. Okay, derivative of sin is cos. So here result is outside the bracket the term as it is, this becomes log of denominator which is sin of x minus a. Here just we take minus outside and write minus. By doing this, derivative of cos is minus sin. So accordingly we substitute log cos of x minus b into, sorry, this is now plus c, the constant of integration. Now we can apply log m minus log n, which is equal to log m upon n. Log m is sin of x minus a upon n mean cos x minus b plus c, the constant of integration. So this is the answer to this question. Question number 4. Evaluate dx upon sin raised to power 4x plus cos raised to power 4x dx. So what is this in this question? What is the special? By quadratic. Okay, so what we do here, we divide numerator and denominator by this cos raised to power 4x. On doing this, we have 1 upon cos raised to power 4x in the numerator, sin raised to power 4x divide cos raised to power 4x becomes tangent raised to power 4x. This becomes 1 into dx. It means numerator becomes secant raised to power 4x divide the same into dx. Now secant raised to power 4x, this we can divide into two parts, secant square x into secant square x, denominator as it is, like this. Now here the first secant square x, we can change this into 1 plus tan square x, because secant square x minus tan square x is equal to 1. So secant square x is equal to 1 plus tan square x. Next is secant square x upon tangent raised to power 4x plus 1 as it is, in this way. Now in the next step what we are doing, we just substitute tangent x is equal to t. Tangent x is equal to t, so its derivative is secant square x into dx is equal to dt. We substitute these values here, so this becomes 1 plus tan square x mean 1 plus t square. Secant square x into dx mean dt divide t raised to power 4 plus 1. Now in the next step we divide by t square, numerator as well as denominator, or we can say taking t square common from numerator, this is 1 upon t square plus 1. Also in denominator this becomes t square plus 1 upon t square into dt. Doing this way, t square is cancelled. Right? Now one rule we have. Suppose t minus 1 upon t, this value is equal to s. Therefore, what is the derivative of this? With respect to t, this is t derivative is 1 minus this becomes plus 1 upon t square. With respect to t, it means dt. Right hand side is ds. Right? So what more we are doing here? What is the square of this? That is t minus 1 upon t whole square is equal to s square. Opening this square, we have a minus b whole square, a square minus 2 into a into b plus b square is equal to s square. So it gives us t square plus 1 upon t square is equal to s square plus 2. So this value t square plus 1 upon t square is equal to s square plus 2 we substitute here, as well as this value 1 plus 1 upon t square into dt equal to ds we substitute here. So this becomes numerator is ds, denominator is s square plus 2. One more thing we can do, 2 mean square root 2 whole square. Okay, now one formula we have 1 upon x square plus a square, its integration is equal to 1 upon a into tan inverse x upon a plus c. So this is the formula of integration. So here a is square root of 2, so the question becomes 1 upon a into tan inverse of x upon a. X mean s upon square root 2. What is s? Taking the original value of s, t minus 1 upon t. Again, what was t? T is tangent x. So replacing t by tangent x, 1 upon square root 2 tangent of tangent x minus 1 upon tangent x whole divide square root 2 plus c. This is the final answer to this question. We follow this trick, that is dividing by cos raised to power 4x whenever denominator it seems to be by quadratic. The question is very important. Now taking next question. Question number 5. Evaluate the limit dx upon 9 cos square x plus 16 sin square x. In such questions also we divide numerator and denominator by cos square x. On dividing numerator, this is 1 upon cos square x. Cos square is divided, so 9 is only there. 16, this becomes tan square x. That is, we can write this as numerator in place of 1 upon cos square x, we are writing secant square x into dx. Rest is everything same. Now in the next step we take tangent x equal to t. Substituting tangent x is equal to t. So the derivative of tangent x is equal to dt. That is secant square x into dx is equal to dt. So this question becomes, on applying this substitution, we have secant square x into dx which is equal to dt divide 9 plus 16 tangent square x mean t square. Now we have one formula. What is that? Integration of 1 upon x square plus a square into dx which is equal to 1 upon a into tan inverse of x upon a plus c. So we are just converting this also according to this formula. How? We can write this as equal to integration 1 upon, taking 16 common outside. So what we are left with 9 upon 16. So 3 upon 4 whole square plus t square into dt. So x square plus a square. X is t, a is 3 upon 4. So our question becomes 1 upon 16 into 1 upon a. 1 upon a is 3 upon 4 into tangent inverse x upon x is t upon a is 3 upon 4 plus c, which again can be written as 4 fours are 16. So this becomes 1 upon 4 into 3 12 tangent inverse 4 upon 4t upon 3 plus c. What is the value of t? This is tangent x. So 1 upon 12 tangent inverse of 4 tangent x upon 3 plus c. So this is the answer to this question. Now next question. Now question number 6. Evaluate integration x square plus 1 divide x power 4 plus 1 into dx. Denominator in biquadratic form. So we take x square common in denominator as well as in numerator. So this becomes 1 plus 1 upon x square whole divide x square plus 1 upon x square into dx. Okay, now what we do, we substitute x minus 1 upon x as equal to t. So its derivative of x is 1, derivative of 1 upon x is plus 1 upon x square, 1 upon x square with respect to x mean dx, right hand side is dt. Also on squaring this, we have on squaring both sides, this one becomes a minus b whole square, that is a square minus 2 into a into b plus b square, that is 1 upon x square, right hand side t whole square. This gives us x square minus 2 plus 1 upon x square is equal to t square, which is again equal to x square plus 1 upon x square is equal to t square plus 2. So now we substitute these two values, 1 plus 1 upon x square into dx equal to dt, x square plus 1 upon x square which is equal to t square plus 2, which again can be written as square root of 2 whole square. So again this is equal to 1 upon square root 2 tangent inverse x mean t upon a square root 2 plus c. Now taking the original value of t, this is becomes square root 2 tangent inverse, what is t, x minus 1 upon x upon square root 2 plus c. So this was our question number 6. Now next question. Question number 7. Evaluate integration of square root of cotangent of x into dx. Solving this question, there is one trick. What is that? Here whole question, that is cotangent of x, we take this as to be equal to t square, right? Mean to say we have taken square root cot x equal to t. So what is the derivative of cotangent x? Minus cosecant square x into dx. Right hand side is 2t into dt. Now cosecant square x, because we know the rule cosecant square x minus cotangent square x is equal to 1. So this way this becomes minus cosecant square x mean 1 plus cot square x, 1 plus cotangent square of x into dx is equal to dt, 2t dt. This way. Now again cotangent x is t square. So what is cotangent square x? This becomes minus 1 plus t raised to power 4 into dx, which is equal to 2t into dt, which gives us dx, the value is 2t divide even minus 2t upon t power 4 plus 1 into dt. So dx is equal to minus 2t upon t raised to power 4 plus 1 into dt. So what is this? Substituting square root of cotangent x equal to t in the very beginning, so cot x was t square. So this question I is equal to integration square root cotangent x is equal to t into dx, value is minus 2t divide t raised to power 4 plus 1 into dt, right? So I is equal to minus 2t square upon t power 4 plus 1 into dt. Now what we do here? Taking minus outside, 2t square mean t square plus t square. Denominator is t power 4 plus 1 as it is. One more thing we can do here, plus 1 minus 1. There is no change. So doing this, first bracket, this is second bracket. Okay. Now again we can write this as, we bifurcated this into two integrals. First term t square plus 1 upon t power 4 plus 1 minus here t square minus 1 upon t power 4 plus 1. Again in both cases we divide numerator and denominator by t square. So this becomes first integral on dividing numerator and denominator by t square, 1 plus 1 upon t square. Denominator is t square plus 1 upon t square. Similarly, the second term, this way, 1 minus 1 upon t square, divide t square plus 1 upon t square. Now one thing we do, we consider here t minus 1 upon t equal to u, t plus 1 upon t equal to v. Therefore, the derivative is derivative with respect to t, 1 plus 1 upon t square into dt is equal to du, and here this is t minus 1 upon t square into dt equal to dv. Okay, so one more thing, taking the square, t minus 1 upon t whole square equal to u square, t plus 1 upon t whole square equal to v square. Now opening the square, we get a square minus 2ab plus b square. Minus 2 will go here. A plus b whole square, a square plus b square plus 2ab plus 2 will go here. Okay. Now we substitute these values. 1 plus 1 upon t square in the first integral, this value 1 plus 1 upon t square into dt, which is equal to du, divide t square plus 1 upon t square is equal to u square plus 2 minus 1 minus 1 upon t square into dt, 1 minus 1 upon t square into dt equal to dv, divide t square plus 1 upon t square, t square plus 1 upon t square equal to v square minus 2. So v square minus 2, right? For the first integration, 1 upon x square plus a square into dx, this rule 1 upon a tan inverse x upon a plus c. So we apply this here, minus 1 upon square root 2 tangent inverse u upon square root 2. Next minus, here we apply this rule, 1 upon x square minus a square dx equal to 1 upon 2a log of x minus a upon x plus a plus c. So this becomes 1 upon 2 square root 2 log of v minus square root 2 upon v plus square root 2 plus c. So what is v? V is t plus 1 upon t. And what was t? This was square root of cotangent x, right? Substituting original values, we get the final answer to this question. So our question is over now. I want to say once again question number 7. Evaluate integration of square root of cotangent x into dx. The question is very important question to the examination point of view. So now let us proceed towards question number 8. Similarly, we have question number 8. Evaluate integration of square root of tangent of x into dx. Here also we substitute square root tangent x equal to t. Square root of tangent x equal to t. So tangent x is equal to t square. Again taking the derivative. Derivative of tangent x is secant square x into dx is equal to 2t into dt. Secant square x, further we can write this as 1 plus tangent square of x into dx, which is equal to 2t into dt. Again this implies 1 plus tangent x equal to t square. So tangent square x is t raised to power 4 into dx is equal to 2t into dt. So what we conclude? We conclude dx value is equal to 2t upon t power 4 plus 1 into dt. Mean to say square root of tangent x is t and dx is equal to 2t upon t power 4 plus 1. So the question becomes integration of t into dx mean 2t upon t power 4 plus 1 into dt. Again this we can write to be equal to integration 2t square divide t raised to power 4 plus 1 into dt. Again, as this is solved in previous question, 2t square mean t square plus t square plus 1 minus 1 this way. So again this is equal to t square plus 1 upon t power 4 plus 1 plus t square minus 1 upon t raised to power 4 plus 1. So again we take two parts. We consider in two ways t plus 1 upon t equal to v u, t minus 1 upon t equal to v. But before that we divide numerator and denominator of both these integrals by t square. So this becomes dividing numerator and denominator by t square, this becomes 1 plus 1 upon t square. Denominator becomes t square plus 1 upon t square. Here this becomes 1 minus 1 upon t square. Denominator t square plus 1 upon t square. Now further we have derivative of u and v. Derivative of t is 1. 1 upon t derivative is minus 1 upon t square with respect to t. So dt, right side is du, right? So similarly here derivative of t is 1, minus 1 upon t derivative is plus 1 upon t square into dt, which is equal to dv. Now taking the square of this, this becomes t square plus 1 upon t square is equal to u square minus 2. Here this becomes t square plus 1 upon t square equal to v square plus 2. So applying these values here, 1 plus 1 upon t square is here. So this is the case, second case, mean to say denominator t square plus 1 upon t square is v square plus 2 and numerator is 1 plus 1 upon t square dt, which is dv, plus here 1 minus 1 upon t square dt is du. Denominator is u square minus 2. Again we consider two rules. First is 1 upon 1 plus x square plus a square dx, which is equal to 1 upon a into tangent inverse x upon a plus c. So this rule we apply here, which becomes 1 upon a is square root 2 tangent inverse x upon a is square root 2, right? And second rule is 1 upon x square minus a square dx equal to 1 upon 2a log x minus a upon x plus a plus c. So this second rule we apply here. Our question becomes 1 upon 2a. A is square root of 2 log of u minus square root 2 upon u plus square root 2 plus c. Finally, substituting the values of u, here this was v and u, we get the required result. So this was our question number 8. Now question number 9, evaluate dx integration 1 upon 5 plus 4 cos x. Here what we do, this is equal to integration of, we apply this rule, cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta, right? Further, which can be written as 1 plus tan square x by 2, this goes here in the numerator. So 5 into 1 plus tan square x by 2 plus 4 into 1 minus tan square x by 2. What is 1 plus tan square x by 2? This is secant square x by 2. Secant square x by 2 into dx. In the denominator, 5 tan square x by 2 minus 4 tan square x by 2 becomes tangent square of x by 2 plus 5 plus 4 is plus 9, right? Now we can take the substitution. What is the substitution? Substituting tangent x by 2 is equal to t, so its derivative is secant square of x by 2 into derivative of x by 2 is 1 by 2 into dx is equal to dt. Mean to say, we can conclude secant square x by 2 into dx equal to dt. So this happens here is equal to 2 dt, and denominator we have t square plus 9, right? So this becomes 2 is outside, integration 1 upon t square plus 3 square into dt, okay, x square plus a square, which again can be written as 2 into 1 upon a is 3 tangent inverse x upon a t upon 3 plus c, right? Further, 2 upon 3 tangent inverse t was tangent x by 2 upon 3 plus c. So this was our question number 9. So we have discussed all the questions, all the important questions